Yeah, so as mentioned, today we're going to dive into a very interesting topic, which is basically on machine learning security. So we're going to talk a little bit about that. Just a bit about myself. My name is Alejandro Saucedo. I'm engineering director at Seldon Technologies. It's a machine learning deployment and monitoring startup. We have one of the most popular open source projects for machine learning deployment in Kubernetes. I'm chief scientist at the Institute for Ethical AI, which is a research center that focuses on developing frameworks for responsible ML and governing member at large at the ACM, which is or sort of private body for computer scientists. And yeah, so as I mentioned a couple of times as people were coming in, some of the resources for the talk, you can find them in this repo. So this is going to be quite a practical talk. So I want to not just show you a bunch of slides, but give you some practical examples. And the way that I wanted to do that is to show you about and tell you about security in machine learning with some practical examples of machine learning gone wrong. And what are some of the potential challenges that may be introduced, may introduce security flaws at each stage of the machine learning lifecycle. So the repo contains some Flawed ML examples that we're going to try to cover in this session. It also has a link to the slides and link to other relevant resources if you want further reading. So let's talk about security challenges in machine learning. So the interesting thing about security in machine learning is that it's not as defined and explored as you would expect, similar to what we have seen in software engineering, in DevOps. There's a lot of practical frameworks that can be adopted, as well as some understanding of what are the main potential security vulnerabilities at different stages. And there's a lot of resources on machine learning applied to security, right? Like things like malware detection or spam filters, et cetera, But what about security in machine learning? So in this session, we're going to be taking a similar approach that was taken in those other fields, try to identify the key challenges of security in machine learning, but also acknowledging that it's impossible to make systems like completely, without vulnerabilities or completely unhackable, right? But what we can do is we can mitigate undesired outcomes, and we can identify those critical or high potential vulnerabilities that actually need to be addressed, as opposed to, try the impossible, which is like making a system completely, fully out of vulnerabilities, which would be impossible. And the solutions will not just be technical, and they will be technical in nature, but ultimately they will still rely on humans and process, right? So that's the key thing. And we're going to be presenting it under the umbrella of this concept of MLSecOps. So there's already a concept of SecOps, security operations, as well as DevSecOps. So this is ultimately kind of like a consortium of all of those different components. So identifying the best practices in the intersection of machine learning infrastructure, DevOps, developer operations and automation, as well as security policies. So that's kind of an angle that we're going to be taking today. Because this is a Python conference, we're going to be actually covering a little bit more of the Python, and we're going to be covering a little bit less of the infrastructure. But as I'm going to reference later, I have other deep dives on different audiences like KubeCon, which is going to be more on the infrastructure side. So there is also a lot of content that we can rely on, right? There's a lot of great research and great resources that have already done the hard work of identifying some potential areas of relevance, specifically in the software world, right? So this is the OWASP, which is the open web sort of like project for security, and they have this very famous sort of resource, which is the top 10 vulnerabilities that they release pretty much every year. And I'm not going to go in detail right now, but you will see that this top 10 vulnerabilities, we're going to come back to them, and we're going to see which are the flawed machine learning vulnerabilities that we can map into this OWASP, like the OWASP ones. And today's talk is not going to be covering the whole spectrum of machine learning, right? Like we're going to be just talking about machine learning security. So it has to be a little bit kind of like succinct, and we have to look over a lot of the more complex parts. But what we are going to be doing under the hood is we're going to be taking a machine learning model, and hopefully a lot of you already have exposure to some kind of like machine learning training, even if it's like the Hello Worlds, like the Iris classifier, which we're going to be using. And we're going to be deploying this model. So actually taking the model that has been trained as its binary, exposing it and putting it as a running microservice, as a service that listens to requests and provides responses. The request would be the prediction input, the response is the output. So we're going to actually identify what are the potential flaws at the different parts of this machine learning lifecycle. So the training, the deployment, the packaging, the monitoring, et cetera, et cetera. If you want to get a little bit more detail, so this is the TLDR, this talk is going to be TLDR on the machine learning deployment. If you do want to actually delve into what is happening, there's talks linked in these slides that you can use, so that you see that it's not like just all hand-wavy and magical. There's some resources behind this. And what we're going to be doing is we're going to first train this machine learning model, and we're going to deploy it using this tool called Seldon Core. This is the tool that allows us to convert our binaries or our Python code into a fully fledged microservice, our machine learning model into a fully fledged microservice. So let's actually do that. So let's take a scikit-learn model with the Iris dataset, right? So that's basically the usual hello world of machine learning. We're going to train a logistic regression model. We're going to fit that logistic regression model, and we're going to test. So we run a prediction. The prediction is an input of a flower and iris, and it predicts what class it will fall under. We're going to then actually take this model that we've trained, and we're going to persist that model because we need to deploy it, right? Somehow we need to say, let's save the model, and then let's put it inside of the microservice. So we're going to actually pickle this model. We're going to see what's inside. We can see that there's actually the logistic regression class. So this is how Python knows how to recreate it. Let's actually copy it into a Google bucket, S3, right? Just a remote bucket that then we can deploy using Seldon, right? So we now have deployed this model. The way that it works is there is a container that runs in Kubernetes, that hand-wavy magic. The container itself pulls the artifact and serves it, right? That's all we need to know. It's a microservice with an endpoint that if we send a request, it gives us a response. The same thing that we saw in our predict function, we are seeing here. Great. We have a model deployed. Easy, simple. And we're ready to go home because the work is done, right? High accuracy model, it's running in production. That's where the life cycle of the model finishes. Unfortunately, that's not the case, right? And we know that with the different stages of the machine learning life cycle, what we have done is, process the data, train the model, persist the model, deploy the model, and serve it, right? So the challenge is now we need to ask the question, what are the areas that actually are at high risk of potential security vulnerabilities? And the only places that are at high risk of security vulnerability are the parts in red, right? So basically everything, right? And we're going to actually talk a little bit about that. We're going to talk a little bit about different parts of security risk in machine learning. We're going to talk about the risks in loading model artifacts, on people getting access to the model or the endpoints of the model, the challenges of the dependencies of the artifact and the servers, the vulnerabilities in your code of your actual model, the vulnerabilities of the images, and then some honorable mentions because I only have 25 minutes and I cannot cover all of the stuff. And even if I had 45 minutes, I wouldn't be able to cover all of this stuff because it's just so much. So the first part, who loves pickles? We all love pickles. We know what pickles are. Pickles are the way in which Python is able to dump a binary and reload it in a different environment. You know who else loves pickles? Machine learning practitioners. They love pickles. They use pickles like there's no tomorrow. And there's a lot of best practice that now moving away into more sort of robust serialization methods. But we're going to see how this actually becomes a challenge with the security areas of pickles. So let's actually load that model that we just trained, right? So this was basically stored as a pickle. That's what we deployed. We're going to just reload it into Python memory. We now reloaded it into this model safe, right? We run the prediction. Model safe still works. Now we're going to do an injection into this pickle, right? We're going to take that function that Python runs to understand how to load the pickle, which is this reduce function. We're going to then inject it into that model itself. This could be run somewhere else, I don't know where, it could be run without the data scientist knowing. The model still behaves correctly. You can still run inference, but the only challenge is that when you actually save that model, what you save is actually something different, right? So what are we saving here? We're saving, this rubbish, whatever it is, for sort of showing. This is just going to copy your local environment and put it in a file called pond.txt, right? And we're just going to show that this actually can run anything, right? Like what I can show is you can actually pull the Kubernetes secrets and store them in a file, or you can pull the Kubernetes secrets and send them into a remote server. You can do whatever you want. You can serve like a SSH session that you can connect to. You can do quite a lot of things. So we're going to now actually copy that artifact. We're going to deploy that artifact into that unsafe model. So now it's running, right? There's nothing wrong because it just loaded it into memory. But if we now look at that container, we can see that the pond.txt file was created. If we actually load it locally, right, we can see that there's no pond.txt file locally. If we load that model locally, we can see that now it creates that pond.txt file, right? So this is just basically saying, like, the pond.txt doesn't, like, kill your computer, but you can actually do whatever you want. So that actually shows some challenges. And the problem is, like what I said, a lot of machine learning practitioners and a lot of, like, very, very, high-profile frameworks use this, right? So major frameworks like scikit-learn, PyTorch, they actually have, especially scikit-learn, they actually tell you this is the way that you actually save a model, right? And the challenge is that there's also exploration. Okay, how do we solve this, right? Do we create some sort of like super intelligent, super smart Codescan, Python scan, Pickles scan libraries that just like check for malicious code? And the actual recommendation is no, right? When it comes to Pickles and when it comes to just running code, even if it's containers, it comes into a trust or discard mechanism. Right? You either have a mechanism in which you can ensure that the artifacts that you're retrieving are legit, irrespective of whether they are Pickles or not. I mean, of course, if you can avoid using Pickles, that's even better because they are dependent on the Python environment, and there are tons of other issues that Pickles bring that are well beyond just security. But there are some considerations to make sure that it is more of that trust and discard perspective, right? As opposed to trying to bring in some sort of like, although there could be some value of exploring some sort of code scans, there are some frameworks that do provide that, which are pretty interesting, and I do recommend checking out, but that is just some key consideration. And as we go through the talk, we're going to be mentioning some of these touch points throughout the CI/CD pipelines, your ETL pipelines, your data science, human workflows that actually benefit from having this trust or discard mechanisms. You need to make sure that there is a trust by design process within the different phases of your machine learning system. And maybe this doesn't make sense when you're just like a team of data scientists who are responsible for the serving of your models. This may not make sense if you're just one data scientist who's responsible of just their Jupyter Notebook and their serving of their model. But this makes sense when you have like multiple business units with data scientists that produce models that then are connected into pipelines through machine learning engineers and then actually monitored by DevOps teams, right? So that's where it kind of like starts making sense for that. Now, second part, this is the kind of like, sexier part of the machine learning security, the one that like everybody talks about, but we don't see as much in the world. And this is what can you do when you have access to the model endpoint or artifact? And this is where the concept of adversarial security comes in. So adversarial security is the ability to be able to take a model and try to ask the question, how can I fool this model? And how can I fool this model whilst fooling a human as well? Right? So from this example, these are some set of images for the CFAR10 classifier that classifies, one of the 10 images, or actually, I think it may be one of the slightly larger ones, data sets. But yeah, so you can see that like these are pictures of a horse, of a truck, and a dog. And after being run through an adversarial example to create an adversarial example, you can see that the picture of a horse with, undetectable human eye, you wouldn't be able to know what actually makes this suddenly a dog, right? Or that truck an automobile, or that dog a horse, right? So this is basically the ways in which you can actually modify an example in order for you to be able to provide that capability of fooling a model as well as the human that looks at it. And it is interesting because ultimately this means that if you just give access to the endpoint of a machine learning model without actually the respective monitoring or logging to understand that there may be some malicious intent to reverse engineer in some way or another the internal behavior of the model, then you may end up in a situation where, people can exploit that, right? And I have, again, an example that shows basically hands-on how you can create this adversarial examples. But yeah, for the perspective of time, I'm not going to be able to dive into it, but you will have more than the ability to dive into it yourself. So the third thing is to just emphasize that once you actually are able to detect that you need to guard your potential model for adversarial attacks, you can introduce things like adversarial detectors. So we actually, at Celdon, have a library called Alibi Detect that provides some state-of-the-art algorithms where you can leverage some of these adversarial detection mechanisms. So it allows you to run this detector in front of your model such that whenever a prediction comes in, you can actually ask the question, is it an adversarial / malicious example? The challenge is that if somebody actually has access to the model artifacts itself, they may be able to find examples that can fool not only the model, but also the detector, right? And the challenge is also, once somebody has access to the model, there are some challenges of not just being able to fool the model itself, but to be able to extract insights from the model itself. So this is an interesting piece of research that talks about extracting training data from large language models. So, and there are some machine learning models that actually require having the data, with the model itself to be able to perform the inference. So those are just some things that you have to take into consideration. If you perhaps break this kind of best practice in some of the parts of your pipeline, you may be exposed to some of these potential challenges. Okay, number 3, dependencies. So the challenge is Python. Python provides a lot of nuances when it comes to dependencies. I'm sure anyone that has maintained a Python library for more than a year would know about this. One day you go home and everything works correctly. The next day you come back and your CI tests are failing. You try to figure out why, and a 4th level dependency got updated, and the 3rd level dependency package didn't pin it, even though you pinned all of your dependencies. And welcome to pip, right? The challenge with the Python sort of dependency management is that this is not something that out of the box you're going to be able to lock, and you do need to make sure that this is a security consideration, because there can be a potential 3rd, 4th, 5th, 20th level dependency that may have been updated with some malicious malware that may affect you. And we have seen a lot of examples, which I'm going to talk a little bit about, of how they are provided. So, here I have some examples where, we can show, some of the dependencies, how with pip_dep_tree, you can see that scikit-learn actually pulls some 3rd level dependencies. You can use other tools like poetry. I don't know, who here has heard about poetry? Raise your hands. Nice, okay, you're all on the good practice. So poetry basically creates a poetry.log file, which is almost equivalent, but not really, as doing a pip freeze into a log file, into a requirements.txt file. But yeah, so basically this allows you to create, a complete sort of lock of your Python environment. Disclaimer, this is just your Python environment, right? This is not your entire, Linux non-Python dependencies, which are the thing that we're going to cover in a bit. And this is challenging because we have actually seen well-intended actions that actually have raised some ethical questions, but that actually reflect the introduction of code that will potentially affect any development library that depends on that specific library. Right? So this is not something that is completely unheard of, that never happens. So it's something to actually be conscious of. So I think that's one thing to mention. And I think, I had one more thing to mention. So there are some libraries that are also kind of improving kind of the infrastructure. So MLflow, there's actually some really great talks at this conference on MLflow. We've actually been doing some collaboration with our Python machine learning server called ML Server. So we actually tackle some of those dependency challenges through the introduction of PyConDE, where we actually are able to dump kind of a freeze of the environment that then the actual microservice can load it. And then using stuff like poetry so that we can actually have a complete reproducible environment. The thing with PyConDE is that it's actually, with PyConDE you have more than just Python, right? You can install Java. I mean, for good or for bad, right? I mean, for some challenges. And there are other things that you can leverage for dependency scans. So you can actually use things like, open source frameworks like Safety Check, which actually checks all of your dependencies, validates whether there are dependencies that have vulnerabilities, dependencies that are actually potentially too, old, etc., etc. So I mean, I think you'll have enough time to cover that on your own site. Code scanning is also important, making sure that you don't have like bad practices on your code itself. We know that there are some potential code vulnerabilities that have now been removed in frameworks like TensorFlow, right? Like they actually had like import from YAML. We know, I mean, if you remember, there was a massive vulnerability with YAML, with the load unsafe that could be exploited, and any framework that had that like was actually reminiscent of that. And ultimately, code scans allow you to like avoid those things. And you can check the code scan example, which basically shows you some like potential vulnerability areas. And one thing to just like bear in mind is that Jupyter Notebooks are no different, right? That's still code until once they grow to a certain level. So that's something to take into consideration. Image scanning, another important thing, making sure that you scan your containers for CVEs and update the internal dependencies. And some honorable mentions, making sure that you actually have your encryption for data artifacts at rest and in transit, authentication, authorization, and infrastructure hardening. There's some really good resources that you can check out there. Again, we talked about the OWASP standards. These are the flawed machine learning equivalents. I'd love to go into a bit more detail, but you will actually like be able to see it in more detail. So this is also kind of like as a bit of a pun, the FML equivalent. And I work hard to get that acronym to work. But yeah, so this is actually quite interesting, and we're going to be working on standardizing them a bit further. So yeah, so the anatomy of production ML, we've been able to like talk about the training, the CI/CD, the deployment. We've been able to also like mention some of the different personas, the data scientist, the machine learning engineer, DevOps engineer, and some further resources that you will be able to find on the repo. And then as a reminder, the resources for the talk are on the ethical ML/FML security repository, where you'll find all of this, right? You'll be able to run it yourself, you'll be able to try it, and if you don't like something, you'll be able to submit a PR, because open source is great. And with that, thank you very much, and I think we are just on time, hopefully.
Yeah, we are even.
Awesome.
Yeah, thanks. You were even a bit faster. So again, please feel free to ask questions on Slido. I don't see one yet, so I will start. Do you think that the security in ML is reflected on the customer side as well? So is this something that there's a concern, or that the customer is willing to pay for? Or what is your opinion on that?
Yeah, that's a great question. So I would say, to specifically your question, yes, absolutely. Like they are like, security is their last name, right? But they're clueless, absolutely clueless. And I just know that because putting together this talk emphasized how little resources there is. There's a lot about machine learning for security, but not about secure machine learning. So yeah.
Okay, great. Then there's a question from Stefan. Have you ever run into problems with fixed and conflicting package pinning?
Have I run into an issue of like sort of configuration management of dependency pinning?
I believe that's the
Yes. Oh, absolutely. Yeah. I mean, you could hear the pain in my voice when I was talking about that. We actually had like we've had several. Like, the one that I remember from the top of my head is like, I remember Azure updated their framework. So like, there's like 20 major versions above. And that just broke like, half of the libraries out there, because tons of them actually had that dependency for some weird reason. And it was like a third, fifth level dependency. And we've also run into this issue when addressing CVEs. Right, like you try to like pin something, and then a second level, third level may have some issues as well. So that's why we just moved to poetry.
Okay, great. Then there's another question. Could you elaborate on how you may be able to detect an adversarial attack with Alibi?
Yeah, for sure. Yeah. Well, so there's actually like an end-to-end example, a Jupyter notebook that guides you with a CIFAR 10 data set. So probably that would cover it in more depth. But the way that I would say it is that the adversarial detector would actually try to get the input of that is coming into the model and try to like see how feasible that is for actually going into the model itself based on the probabilities of the output. So that would actually like work in tandem with the model. So it's quite an interesting area of research. So I would recommend to check it out.
Okay, great. Are there other questions? I think then thank you for your time. Thank you for the amazing talk. And
awesome.
See you around.
Thank you.